first. What was the rule?
Y equals x squared minus 6x plus 8.
Minus 6x?
Plus 8. Right.
All right, we here? I'm ready. Oh, okay. All right, so let's look at this. Key features. What can you tell me about this parabola that you know already just by looking at this in standard form? The y-intercept thing is 8. So I'm looking for this thing to cross the y-axis at what? 8. I'm just going to put a point here because it say 8, so that's where it goes. Right? That's a point I already got, right? What else do I know?
It's going to the right.
It's going to shift to the...
Or the left.
I don't know.
The left.
How do you know?
The right. Negative 6.
8, not because the A is positive.
It's negative because 1.
Wait. What do we have to do to figure out this shift left or right? A times B. Positive times positive is positive. So which way are we going to be? Left.
Wait, but B is positive.
Both. Oh, B is negative. Sorry. Yes. So A times negative. Oh, positive times negative is going to be negative. So then it's going to shift to the what? Right. Very good. Very good, China. So that means the vertex is going to sit somewhere on this side of this y-axis. Are y'all with me?
Yeah.
So right now I'm imagining it doing something like this. Are y'all with me?
Right.
We know that it used up because the A is positive, right? So if I look at a multiple choice answer and they say the solutions are negative 10, I already know that's a lie. Negative 10 can't be the solution because negative 10 is on the left and this thing is Uing like this because the vertex is sitting on the right. You see what I'm saying? Like you can eliminate some things based off what you see. Now, how do I know there is going to be a shift? Because there is a B. Are y'all with me? All right, so now let's go. What am I looking to do? I need to graph this thing. So let's graph it. What do I do? No, I'm at vertex. That's the first thing I would do. Let me find this vertex real quick, right? So what is our rule? It is y equals x squared
Minus 6x plus 8.
All right, so how do we find our vertex? X equals negative b over 2a, right? All we're going to do is plug in right now. You working with me, right? So we got negative times, what's my b? What's my b?
Negative 6.
What's my b?
Negative 6.
So what's going in here? Negative 6. Do I put just 6 because there's already a negative?
No.
No.
It was already like that.
Right? Exactly. So it says, so now 2 times, and what's my a? 1. Everybody with me so far?
Yeah.
All right. Now I can put that imaginary coefficient here if I want to, or I can just look at it and say I got a negative 6. I need the opposite of negative 6. What is that going to be?
1.
Whoa. What is the opposite of negative 6? I ain't going to say your name out loud, China. Okay, so then what's 2 times 1? 2. So then now 6 divided by 2 is what? 3. What is this 3?
Our axis.
X is my axis of symmetry. Absolutely. It is my axis of what? Symmetry. But what else is it? The X of my vertex. Now I need the Y. Plug it in. That's always the answer. You got an X, plug it in, get the Y. If you got a Y, plug it in, get the X. All right, so now let's plug in. And I'm going to have Y equals, in parentheses what? 3. Minus 6 times what? 3.
Square.
Oh, thank you. Don't forget that. It's very easy to forget. My pen cutting up again. Plus 8. All right. Now, grab your calculators. What are we putting inside of the handy dandy calculator? I'm just going to leave it big. Y'all can do it for me, right?
Yes.
What's 3 squared?
9.
So we got 9. Am I dropping this minus automatically? No. What am I putting in my calculator?
Negative 6.
Negative 6 times 3. What do I get?
Negative 18.
Negative 18. And then I'm bringing it down. Plus 8. Everybody good?
Yes.
All right. Now, you just put in the calculator.
Negative 1. Yeah.
Can somebody double check that?
Yes.
Yes? Negative 1?
Yes.
Negative 1. So, do I know my vertex now? What is my vertex? I put in a 3 and I got out a -1. To be honest, I'm almost done. Once you get that vertex, you got magic. Like, you don't got much else to do, right? Unless they give you some funky numbers to play with, it's like not difficult at all. So we are here. I'm gonna put this over here, and then I'm gonna look at this. So what did you just tell me our vertex was? 3 and -1. So I'm gonna go here where it says vertex, and I'm gonna put here 3 and -1. You don't have what, baby? Three and -1. Everybody good there?
Yes.
You can just write it in. You're welcome. All right. What am I gonna do now? I'm gonna plot that point, aren't I?
Yes.
I'm gonna go right 3 and down 1. So start at the origin. I'm gonna go right 3 and down 1, and I got a point that goes right here. Now remember, how many points do you need to make a parabola? You only need 3. What can I put right down here? Through here. So I'm gonna do this just so I can see this line going through. Is everybody with me? Now watch this. I could really be done, because don't I got a point already here for my y-intercept?
Yes.
And it's 1, 2, 3 to the left.
Yes.
So I can make one that's 1, 2, 3 to the right. And look at that. I got 3 points. I'm doggone near done, aren't I?
Yeah.
All right, but I can't really see my my x-intercepts clearly, right? So I want to do a little bit more, okay? So what do? I got options. Here's one thing I can do. Now look at this. This is sitting on the 3, right?
Yeah.
I can plug the 2 into the equation. See what I get for the y. That could be that point. Plug the 4 and then just reflect it where the 4 is. Are y'all with me? That'll give me 2 more points. Are y'all with me? This is the 0. I can plug in a 1 into the equation and see what it gives me out. Or I can plug in a 5 into the equation and see what it gives me out, right? So I can do those things here in this T-chart, right? We can plug in a 1. We can plug in a 3. No, not a 3. We already got the 3. We can plug in a 1 and a 2, right? And then if I plug in 1 and 2, do I need to plug in 4 and 5?
No.
No, why not? Because you can just reflect it, right? So that's one option. What's my other option? 1, 3, 5, right? So what could I do? I could say 1A, 3A, 5A, right? What was my A? My A was 1?
Yeah.
So this is 1 times my A was 1. So 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is 5. Man, let's go a little further. 7A. 7 times 1 is 7. So how do I use that? I start at the vertex. And I go right 1. But then I go what? Up 3. I go up 1. Then I go right 1 again and go up 3. Then I go right 1 again and up 5. I go right 1 again and up 7. What if those would have been negative?
Down.
So go right 1 and then down 1. And right 1 and then down 3. Are y'all with me? Yes? Miss Stamina, where you get those numbers from? If A is equal to 1, 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is 5. Do y'all see where I'm getting that from?
Yeah.
Let's do these other points. I'm starting here. And I'm going to use the first 2. What do I do?
Right 1.
Right 1,
Up 1.
up 1. Yeah. Look what I just found.
X.
I found my x-intercept.
One of them.
Y'all see that?
Yeah.
Come on, Guido. You was doing excellent.
Why don't we finish?
Then what I'm going to do? I'm going to go right 1 again. But this time, I'm going to go what?
3.
Up 3. So right 1, up 1, 2, 3.
That's it.
That's it. That's really it. Because what can I do to get this other side?
Reflect.
Reflect. This is 1 point to the right. I need 1 point to the left. This is 1, 2 to the right. That's why that axis symmetry is so important, right? It's your reflection line. 1, 2 to the right, so 1, 2 to the left. And guess what, y'all? Aren't I done?
Yes.
I'm done. What about the person who says, but Miss Stampley, I don't get the 1, 3, 5 thing. Is there another way I can do this?
Yeah.
Is there? Yes? Let's
Yes.
do this 1, 2 thing real quick. What was the equation that we were given?
X squared minus 6x plus 8.
So let's plug in a 1 for these x's, right? Y'all with me?
Right.
What am I doing? I'm trying to see if I can get other points, okay? So if I know that my vertex is here, I'm just going to pick points around my vertex to plug in x's and see what I get for the y's. So if I plug in a 1 right here, I got 1 squared. Y'all with me?
Right.
Minus 6 times 1 plus 8. Y'all following?
Right.
Yes? All right, so what's 1 squared?
1.
1. And what's 6 times 1?
Negative 2.
So you got 1 minus 6 plus 8. Calculators. What is it? 1 minus 6 plus 8. What do we end up with?
3.
3. So that means if you plugged in a 1, you should get out a what? 3. So this ordered pair is 1, 3. And if I go 1, 3, right 1, up 3. Did I hit that point?
Yes.
That's another way we could have got that point. Are y'all following me? Then we would have did the same thing, plugged in a 2. Let me just prove it to you. If I plug in a 2, instead of these 1s, plug in a 2 here, and a 2 here. 2 squared, what's that?
4.
4. 2 times 6,
Negative
12. So I got 4, take away 12 plus 8. Calculators. 4 minus 12 plus 8. What do we get? 0. So we plugged in a 2 and got out a 0. What does this tell me? It got to be an x-intercept. That's another solution because I got a 0 as the y. So I'm going to go right here, put this 0, and bam. Right? 2 up, nothing. That was my other point. Easy. Are y'all following?
Yeah.
We have options. Now let's do the rest of this table. What does the rest of this say? What was my A? 1. What's my B? 6. Negative 6. What's my C? 8. All right, concavity, up or down? Ooh, mixed emotions. Up or down? My concavity, is this thing bending up or bending down? How we know it's up? Because what's positive? The A. So then why are these other people talking about down? China, I ain't gonna say your name again. Up. Do we have a maximum or a minimum? Minimum. Everybody good there? All right. Now, do we have a stretch or a compress? Oh, I thought y'all was gonna get this right. When is it stretched? When it's greater than 1. When is it compressed? When it's less than 1. Thank you. That's what it is. It's not either. It's neither. Why? Because it's not greater than 2. Greater than 1, and it's not less than 1. Are y'all following? All right, come on now, don't be forced to put an answer.
Compressed is greater than 1, stretched is less than 1?
No, the opposite. Watch this, China. Look, 0. A is 0. It's linear, right? These are fractions. 1/2, 1/3, 1/5, whatever, right? This is compressed. This is wide. It's wide. When you get to 1, it's neither. But then as we keep going, it's getting more narrow. So it's compressed. So the bigger the number is, the farther it is from this line. And the farther it is from this line, the more stretched it is. Okay. It's like a rubber band being pulled up, right? So it's neither, but if it was stretched, it'll be greater than 1. And if it's compressed, it's less than 1. Basically, the cheat code is if it's a fraction as your A, it's compressed. Are y'all with me?
Yeah.
Yes? All right, now let's talk about this. What's our y-intercept?
8.
It was 8. Positive or negative?
Positive.
Talk to me about this shift. You should know this.
Right.
It should
Right, how much?
3.
3. And then what?
Down.
Down, how much?
1.
1. Are y'all following?
Yeah.
All right, it's down 1. Now, talk to me about these x-intercepts. We found our solutions. What are our solutions? Where did our parabola cross the x-axis? 2 and what? 4. So I'm going to write this as 2, 0, and what? 4, 0. How many solutions did I have? 2. Oh, what about our domain? What's our domain? What does domain mean? It means which x's are affected. Well, x's run like this, right? How wide does this go? Because it's not stopping right here. We just stopped there. But remember, what's on the end of these things? It's arrows. So tell me, will this ever stop going left?
No.
Will this ever stop going right?
No.
So then left to right, are there any numbers that we miss? Or are all numbers included? So then we put all real numbers. And this will always be true for every domain of a quadratic function. I don't care what it is. From left to right, whether it's going up or down. It goes from here all the way over here. It got arrows on the end. It's going to be every number from negative infinity to what? Positive infinity. Doesn't stop. Are y'all following? Yes? Now what about the range? Now for the range, it's going to be different when you do quadratic. Why? Because range deals with the y. It's how far up and down. So you told me this thing has a minimum, right? So if it has a minimum, that means it has a lowest point. It goes all the way up forever, but it doesn't go down forever. Are y'all with me? So what is the lowest y? Negative 1. This thing stops right here. Are y'all with me? So therefore, watch what I write. My range, which deals with my y's, is going to say all my y's are going to be what? Greater than or equal to negative 1. Every y we deal with is greater than that. Why? Because we don't deal with no y smaller than that. Look at this. Here's the y's, right? That's negative 1. Do we have any points down here?
No.
So nothing below negative 1 is true. But negative 1 on up, don't we got a bunch of points? Yes. So then this is going to be y is greater than negative 1. Greater than or equal to negative 1. Does that make sense? Yes? Domain, always, all real numbers. But your y is going to be based on whatever your y is. And here's how you know. Look at your y. What is it? So then it's going to be negative 1. It's either going to be greater or it's going to be less. If it used down, it's going to be less than. If it used up, it's going to be greater than. All right, so let's fill out the rest of this. We know the standard form because they gave it to us. What was it? Y equals x squared.
Minus 6x plus b.
All right, now vertex form. Do we know our vertex?
Yes.
What is our vertex?
3 negative 1.
It's 3 and negative 1. So let's put it in vertex form. I'm going to write vertex form so we can see. Vertex form is y equals a times x minus h squared plus k. So help me out. If this is my vertex and this is my vertex form, I need my h and my k, and I also need my a. What's my a? 1. So let's go. Y equals 1 times x minus.
3
What if this would have been a negative 3?
plus 3
Absolutely. Minus 3 what?
Squared.
Squared. And then what about this?
minus 1.
Minus 1, because that stays the same. That case stays the same. Good job. Do you understand that?
Yeah.
That back row is not looking too good. All right, last one. Factored form. Factored form gives us our solutions. Do we know our solution?
Yes.
Yes, so can we write factor form?
Yeah.
All right, so factor form is y equals
1
a times x minus p times x minus q, where p and q are the opposite of our solutions. Are y'all with me?
right.
All right, so let's roll. What am I doing? Y equals
1
1 times.
x minus 2 times x minus 4
What if our x was a negative 4?
plus 2.
We'd have put
Okay, plus 4.
correct. Plus 4. Are y'all following? This is, do y'all see how we can do all these forms from this?
Right.
How graphing really can help us with all these different things that we need to find? Yes? Are there any questions on any of this? No? All right. So I know we only have a few minutes, but I'm going to give you a problem, and I want you to work on it. Everybody got it?
Yeah.
You're going to graph it as the second one on your paper. And I'm going to give you that problem. The problem is y equals negative 2x squared minus 4x plus